Hello everyone, I'm Jung-Chul. OpenStack Administration course Chapter 9 Networking Service Neutron. Main topics. In this video, you will study Introduction to Neutron and Neutron Components and how to install Neutron packages and how to configure Neutron service, how to start Neutron service, and the last topic will be how to create Neutron networks. What is Neutron? So, Neutron is networking service provided by OpenStack service. Using Neutron, we can create virtual compute environment. And also, using Neutron, we can provide network virtualization in OpenStack, especially for Nova service. At first time, Neutron was the Quantum API, but now the Neutron has replaced this original networking service. So nowadays, we normally use the Neutron instead of the Quantum service in OpenStack. At first time, using Neutron, we can provide the plugin the mechanisms. This kind of plugin mechanisms can be flexible in various different technologies via the Quantum API. Even if each company is using very different technologies, but if they use the Neutron, this kind of plugin using the plugin mechanism, they can control all these kind of various and different technologies based on the networking service. If you are successful to set up and start a Neutron service, then using Neutron, we can create the multiple private networks. Also, it is very easy to control IP address for each tenant domains based on Nova service. Also, Neutron is very excellent to provide the rich networking topologies, also advanced network policies in the cloud, such as the LB, AAS, LB mean load balancing, and the VPN, firewall, IDS, and the data center interconnect as well. If you check this kind of the relationship with the Neutron and other components, in chapter 6, I already show you how to use the compute, this one Nova service, and now we are studying this one OpenStack, number 3, OpenStack Networking service. If you check the OpenStack Networking, always OpenStack Networking must be connected to this one network connected with the Nova service. So OpenStack Networking exists to provide their service to compute. Compute means normally it's a virtual machines based on created on Nova service. Okay, let's check the Neutron, the logical architecture. This kind of Neutron server, Neutron agent, Neutron plugin, or network providers, this is a kind of the Neutron component. So at first, the Neutron server must be run on controller node, then this one Neutron server always is ready to receive the request from the client to allocate IP address. Then Neutron server need to transfer this kind of request to Neutron agent and Neutron plugin through message queue. Then Neutron agent, Neutron plugin will receive this kind of request from Neutron server. Then these two agent and plugin need to save this kind of request to database. And after that, Neutron agent need to command this kind of request to network providers. Then network provider will allocate this kind of IP address according to user's request. Also, Neutron agent need to update their request to database frequently. So let's check the one by one. At first, user request IP allocation to Neutron server, and always Neutron server is ready, must be ready to receive this kind of request from the users using this kind of Neutron API. And number 2, Neutron server transfers this kind of request from the users to message queue. In this video, I'm using RabbitMQ server for message queue service. And number 3, This kind of message queue now the commands the Neutron agent, Neutron plugin to allocate IP addresses for virtual machines. This kind of the commands come from where user request, and now the Neutron server need to transfer this kind of request to Neutron agent and plugin using message queue. And number 4, then Neutron agent, Neutron plugin will save this kind of request to database, and Neutron agent the commands network provider for what? To allocate IP addresses. And then Neutron agent also need to update this kind of the request to Neutron database frequently. Okay, let's check basic deployment. At first time, Neutron server must be run in controller node, and the Neutron server need to be communicate with the database. And the Neutron server also always must be connected to message queue to communicate with L2 agent, L3 agent, and DHCP agent as well. This is a basic deployment on Neutron service. So let's check Neutron components one by one. At first, in controller node, we need to enable two networking services. This one, Neutron server and ML2 plugin. ML2 means modular layer 2. In the networking node here, networking, modular layer 2 plugin, layer 2 agent like OBS. OBS means OpenvSwitch. And the layer 3 agent and DHCP agent as well. Using this kind of network agent, normally network node will provide networking service to compute node. So in compute node, need to connect it to networking node using this kind of networking service such as modular layer 2 plugin and layer 2 agent, OpenvSwitch. Each compute node always this kind of the layer 2 agent must be enabled to communicate with this kind of networking node. Using this kind of the relationship, always compute node will provide the networking service to virtual machines. So I already told you Neutron the server accept and route API requests from the client or users, and of that to transfer these kind of things to appropriate OpenStack networking plugins. Also, Neutron server enforce the network model and especially the IP addressing of each port. For this kind of purpose, all the virtual machines need to use this kind of virtual interfaces, and this kind of virtual interfaces for IP addressing need to be connected to port in layer 2 agent. Plugin agent will require access to database. I already told you all Neutron server need to be connected to database for persistent storage. For the persistent storage, need to be checked in database by the Neutron server as well. Also, need to access the message queue for intercommunications with the other compute node. L2 agent normally need to run on each compute node. So L2 agent must be connected, must be enabled or run where in compute node based on Nova service. Using this kind of L2 agent, we need to manage local virtual switch configuration. We normally call vSwitch. In this video, I will use OpenvSwitch. And the L2 agent communicate with the server. Server means Neutron server via RPC. RPC means this kind of message queue service. If we are successful to start or run this kind of L2 agent, normally L2 agent need to watch and notify when the device is added or removed. Whenever we create this kind of the virtual machines need to add their interfaces. Then this kind of interface need to be connected to this kind of L2 agent such as OpenvSwitch. Whenever this kind of L2 agent receive this kind of request from the virtual machines, then always L2 agent will watch and notify. Also, L2 agent wires new devices with proper network segment and the security rules. About the network segment and the security rules in the next part I will explain. L2 agent also require message queue access, such as RabbitMQ server. DHCP agent normally provide DHCP service to tenant network. About the tenant network also, later I will explain about this one. Same across all plugins and are responsible for maintaining DHCP configuration. If you want to provide a DHCP service to virtual machines based on Nova, then your networking service must use this DHCP agent. L3 agent provide L3 and NAT forwarding for external network access of the VM virtual machine on tenant network. At first time, tenant network will receive or will be assigned to use normally private network address. This kind of private network address cannot access external network access like internet. So for this kind of purpose, the L3 agent needed to provide L3 the networking for external network access like internet to where? To this one, virtual machines on Nova. Also, this one needed to require the message queue, and the L3 agent will use the namespaces like DHCP and the router. In this video, I will show you maybe in this the last part when I create networking service, then normally networking node will have this kind of namespaces. Network provider service provide additional networking service such as this one. Okay, SDN services may interact with the Neutron server, Neutron the plugin, and the plugin agent through the communication channels such as REST API. So using this kind of API, always communication channel will be open between this kind of tenant networks. So let's check the Neutron networks here. Here you can find 4 kinds of Neutron network types. At first, management network type. Second, external network type. Third, guest network type. And the last is API network type. So in case of the management connected to network node, SDN service, compute node, and the controller node. In case of the external, normally connected to only network node, guest network types must be connected to network node, SDN service, compute node. Also, the other compute node for interaction with this kind of internal networks. API normally connected to controller node or dashboard node. Let's check one by one for this kind of network types. Okay, at first, the management network used for internal communication between OpenStack components. So if you are deploying the 3 kinds of types like compute node, network node, or controller node. So in this case, maybe you need the communication between this kind of node. Then for this kind of purpose, we can use management network. IP addresses on this network should be reachable only within the data center and is considered the management. From the outsiders or external networks cannot be accessed to this management network. Only management network must be accessed within data centers. External network used to provide the virtual machines with the internal access in some deployment scenarios. It means that I already told you, virtual machine at first time will receive the private network addresses without connection to the internal access like externals. So in this case, external network can enable the virtual machines to access internal access as an external network. And the IP addresses on this network should be reachable by anyone on the internet. Any users in the internet can access this kind of IP address because this is an external network address. So this one considered to be in the public security domain. Guest network used for the virtual machine data communications within cloud deployment. If you are successful to make a cloud and each cloud will have the IP address for the internal communications. For this kind of purpose, we can use guest network. And the IP addressing requirement of this network depend on OpenStack Networking plugin use. For this kind of purpose, always your networking node and the compute node must enable this one plugin service. And we call this one the consider guest security domain. API network expose all OpenStack APIs, including OpenStack Networking API to tenants. It means that all OpenStack components must be connected to this API network because users can access this kind of OpenStack component using this kind of API network. And this kind of API network also needs to be connected to the tenant. And the IP address on this network should be reached by anyone on the internet. I already told you, any users can access, must be able to access this kind of the OpenStack APIs. Then this kind of OpenStack API must use this kind of API network as your external to access like internet. This may be the same network as the external network. I already told you, external network can access the internet. API network also must access the internet as well. In this case, API and external can use the same network address as well. We normally call this one public security domain. Neutron deployment architecture. So here you can find, I already told you, the API can access this kind of the service node, and this kind of service node must use the public or API network address to enable network access from the internet as an external network. So at first time, the service network will provide networking service as like a Neutron server and networking plugin like a Modular layer 2. And this kind of networking plugin must be connected to database, and this kind of service node need to connect it to or communicate with this kind of computer node and network node using or through the message broker service. So networking node needed to provide DHCP agent, L3 agent, L2 agent, metadata, proxy, and these three network services must be connected to the service node or the computer node using or through the message broker. Also, networking node needed to the metadata proxy service, and this service must be connected to Nova metadata service. Computer node, only computer node will provide virtual machines to users. Computer node also need to provide this kind of L2 agent service, and this L2 agent service need to connect to message broker to communicate with this kind of service node and network node. So service node means expose the OpenStack networking API. Using this networking API, users can access all networking services. So here, handle incoming requests from users. And this service node also hosts both OpenStack networking service itself. We normally call this one like a Neutron server, and active OpenStack networking plugin like a Modular layer 2. In this situation so far, I use the controller node instead of the service node. So if we are using now the controller node, and this kind of controller node must host the client, the facing API, it means all incoming requests can access this kind of API and schedulers. Then controller node also to fulfill the role of the service node. In this video, instead of service node, I will use the controller node as a service node role. Network node handles the majority of the OpenStack networking workload. So for this kind of purpose, network node needed to enable this kind of service, DHCP, layer 3 and layer 2, and metadata proxy service as well. Normally, this kind of network node runs on instance of the plugin agent. So the instance also must be connected to plugin agent in computer node to receive this kind of services from network node. For this kind of purpose, network node will use OpenSwitch and Linux Bridge for plugin service. Computer node run the computer instances themselves. In chapter 6, I already show you how to create this kind of virtual machines on compute the service Nova. And this kind of computer node to connect computer instances to the OpenStack networking service. Normally, computer node must also run the L2 agent. In this video, I will use the OpenvSwitch as your L2 agent per each computer node. In case of the L2 agent, normally just handle data package. So For this kind of purpose, we need to run the instance with the plugin agent. Normally this one, L2 agent. OpenStack Networking, the API. Normally Neutron service should provide the powerful API to define network connectivity and addressing. Neutron only can be used to provide the network connectivity and addressing, especially to whom? To Nova service. Neutron service needed to provide a powerful API to define for what? I already told you first time the definition of the Neutron. Neutron need to provide network service. Then this kind of network connectivity and the addressing IP addressing need to provide it to which one? This one, compute node service like Nova. Only for this kind of purpose we can use network API. Using this one, this kind of networking API can use three kinds of component for their purpose. This one, virtual network, subnet, and the port. So next page I will explain about this one. First one, network. This one means unisolated L2 segment analogous to VLAN in the physical networking world. It means that network is similar to VLAN. VLAN means it's the virtual LAN. Virtual LAN means that it can create barriers or the different network address in the same switch. Even if we are using one switch, but in this one switch we can create barriers for the different network addresses. Normally we call this a virtual network. Subnet or block of the version 4 or version 6 IP addresses. If we are successful to create this kind of the virtual network, then this kind of virtual network must have the subnet address, and this kind of subnet address means it's only IP version 4 or IP version 6 addresses. Port means the connection point of attaching of the single device, such as the NIC of virtual server to a virtual network. Each virtual machines and each the switch will have this kind of port to connect each other, and especially this one, NIC network interface of the virtual server. Virtual server must have this kind of port connection with this one, network service. Also describe the associate the network configuration such as MAC and IP address. And normally this kind of port must have at least two kind of factors, MAC address and IP address, to use this kind of port, the concept in the networking, OpenStack Networking API. So here, let's check here. At first time, we can create this kind of virtual machines in Nova. And this kind of virtual machine, each virtual machine must have this kind of IP address. And this kind of IP address must be connected to this kind of tenant. Tenant A, net 1, tenant A, net 2. Tenant B, net 1, tenant B, 2. So tenant means a kind of the domain which use the separate network address. For example, tenant A, net 1, now using network address, this one, 10.10.10.0/24. Tenant A net 2, 10.10.20.0. Tenant B net 1, 10.10.10.1. In this case, tenant B and tenant A are using the same network address, but no problem because their network name is different each other. So this is a kind of concept of the tenant. So each virtual machine need to connect this kind of tenant. And this kind of tenant can have the various network addresses. This one means 10.10.10.0. This kind of things is a subnet information using IP version 4. And this kind of tenant need to connect to the router. This kind of tenant, all tenant must be connected to router to connect this kind of public network addresses. And in this previous page, I already explained the concept of the port. Port means here, each virtual machine needs to connect to this kind of tenant. In this case, this kind of tenant network can be used on the OpenvSwitch switch as your L2 agent, and this kind of OpenvSwitch switch will have the port to connect with this kind of virtual machines. So from this one, OpenvSwitch switch and the router service and the public net connections. For this kind of concept, we can use what? The Neutron. Neutron will cover these areas. And virtual machines, to create how to create virtual machines, Nova will cover this kind of virtual machines creations with this kind of IP address. So networking, the API extensions. OpenStack Networking API allows plugin to provide the extensions. It means a kind of the additional the functions on Neutron the service. So especially three kinds: provider networks, L3 routing and NAT, and security groups. This is a kind of networking API extensions. Okay, let's check one by one. First, the provider networks. So provider networks is a kind of virtual networks, and this kind of virtual networks need to be the map directly to network in the physical data center. Each this kind of data center must have the physical data, and this kind of physical data must be connected to this kind of virtual networks created by the providers. Also, this kind of provider networks allows the administrator to give the tenant direct access to public networks such as internet. In previous page, I already explained tenant network will have normally the private network address, and this kind of virtual machines which bring this kind of network address from the tenant must be connected to the public network address like internet. In this case, provider network needed to provide this kind of network to this kind of virtual machines. For this kind of purpose, provider can use what? VLAN on the switch. Provider extension is the enabled OpenStack networking users with the administrative privilege are able to see additional provider attribute on all virtual networks. So for this kind of purpose, always you need to check the provider extension is enabled or not to provide this kind of service. For the provider networks, we can use this for OpenvSwitch and the Linux Bridge. This kind of plugins can support the provider network extensions. In this video, I already told you for this kind of purpose or the provider network creations, I will use OpenvSwitch. L3 routing and NAT. Normally L3 provide abstract the L3 the routers. Using this kind of L3 router, API users are able to dynamically provision and configure. For the L3 routing, we need to create this kind of L3 routers. Using this kind of L3 routers, users can access their service, and after that they can configure and provide dynamically their service using L3 routers. So L3 this kind of routers can provide the gateway. This kind of gateway can connect the private L2 network and external network as well like internet. Also, this kind of the router can provide the NAT the service. This kind of NAT service can provide the connection to external network address. Router also can support the floating IP addresses. Using this kind of floating IP addresses, anytime we can provide the connection between private and public network addresses. External network always can access this kind of public IP addresses. So floating IP address must be belong to public IP address, and this one can connect to private IP addresses as well. And this private IP address always must be attached to L2 networks, like OpenvSwitch. If the external IP, the public network can access this kind of some the instances based on the Nova, then this kind of the instance can be selected, the exposures, selective exposures to the external public network address. Then this kind of the compute instance must have floating IP address. So floating IP address can also able to be relocated to different OpenStack the networking post as necessary. It means that even if we assign the plotting IP address, but also we can use this kind of plot already the assigned plotting IP address for the other networking posts as well. Security group, this is a kind of the rule to filter the type direction of network traffic. When the virtual machine send their traffic to the OpenvSwitch, then each the OpenvSwitch needed to filter their the type and the direction from the virtual machines. For this kind of purpose, we can use the security groups. So security group can provide additional layer of the security to complement any firewall rules. So just think, security group is a kind of rule for what? For the security. And for this kind of purpose, we can use what? Firewall rules. Security groups is a kind of container object with the security ingress and the egress rules. So if your virtual machine permit the access from the internal or the external, in this case, your security group must have their own the rules for ingress and egress network access. Normally, this kind of security group must include this one, the port for the plotting IP address, or the networking, the load balancing service, and the router, the interfaces, or the instances. So when we create this kind of the plotting or router, the instances, interfaces, or the instances on Nova, normally must have the security group. Also, security group can support the overlapping the IP and the virtual machines with multiple virtual interfaces. Even if your virtual machines have the multiple virtual interfaces, no problem because of this kind of the separate security group. If you are successful to start your virtual machine with the security group, then this kind of security group will have the default rule. By this kind of default rule, your security group will drop the inbound traffic and allow all outbound traffic. So inbound traffic means the internal traffic. The outbound traffic means the external traffic. Using security group, we can add the additional the security rules. If you need more the security anytime, you can add this kind of rules to security groups currently. Okay, OpenStack Networking, the plugins. Neutron can provide this kind of the plugins. Using this kind of plugins, we can implement the backend the features for OpenStack Networking API. And this kind of the plugin can use variety of technologies to implement the logical API request. It means that according to each company, they can use various networking technologies. In this case, using networking plugins, we can control this kind of various or the different technologies. So we need to use this kind of plugin, the service in Neutron. And some OpenStack networking plugins might use basic Linux VLANs and the firewalls. So VLAN, normally we can use this kind of VLAN in the L2 like a switch. And the firewall, also we can use various the firewall the service. And so this kind of plugin, this kind of Linux VLAN or the firewall, we can implement the Neutron plugin, the service as well. Here, others might use more advanced technologies such as L2 in the L3, the tunneling service. Later I will implement the tunneling, or OpenPro as well to provide a similar benefit. So using networking the plugin service, we can implement this kind of tunneling service, OpenFlow service. Even if we don't have this kind of the specific tunneling technology or the OpenFlow, but using networking the plugin service, anytime we can implement this kind of service. For this kind of purpose, Neutron can provide various plugin services like this: the big switch, broad, or the Cisco, Linux Bridge, OpenSwitch, or the other OpenFlow as well. But even if there are many kinds of the Neutron plugins, but this one, Modular Layer 2 is a standard of these networking plugins. So, the Modular Layer 2 plugin, in case of the compute in Nova Service API, we normally are using the Azure Standard KVM. For the storage API, we are using the Ceph in Azure Standard, and networking API is this one. Modular Layer 2 plugin is a standard plugin in OpenStack Neutron service. In case of the users, to access this kind of API, normally use the GUI or CLI or directly using API can access this kind of service as well. So, Modular Layer 2. Modular Layer 2 is core plugins, and this was introduced in OpenStack Habana service. And Modular Layer 2, this one, designed enables the concurrent operation of mixed network technologies. According to each company, they're using so various or different network technologies. In this case, how can we provide the profit, the layers? So, using Modular Layer 2, we can control various the mixed network technologies. Especially OpenvSwitch and the Linux Bridge plugins have been deprecated, will be removed in future releases. It means that before Modular Layer 2, for this kind of purpose, we have to use OpenvSwitch or Linux Bridge or the other things to sort. But if they are the separate or different this kind of plugins, then they could not communicate each other. For example, A company using OpenvSwitch and the B company now Linux Bridge. In this case, they cannot communicate each other using OpenStack networking service. So nowadays, using Modular Layer 2, even if many companies use the mixed or the barriers, their network technology, no problem to communicate each other using this Modular Layer 2 plugin. So this one, this kind of OpenvSwitch or Linux Bridge, their functionality instead been re-implemented as ML2 mechanism. It means that only even if we use Modular Layer 2, we can use this kind of OpenvSwitch or Linux Bridge for our virtual machine service. So now the Modular Layer 2 is the default OpenStack networking plugins. And for this kind to configure or to implement this kind of the Modular Layer 2, normally we use OpenvSwitch or Linux Bridge, but in this video I will use OpenvSwitch. Network types, multiple network the segment types be operated concurrently. When we configure Modular Layer 2, Modular Layer 2 needed to support the segment types. So this one, the segment types for this kind of purpose here, this kind of network, the segment can interconnect using Modular Layer 2 support for multi-segment networks. In Neutron API types, I already explained about the three kind things for this kind of network types, like a virtual network and the subnet and the port. For this kind of network type, we can use here segment types, and the port are automatically bound to the segment with the connectivity. So segment normally will be a virtual network, and this kind of virtual, if the virtual machine receive this kind of virtual network, and always this kind of virtual machines, the network interface need to be bound to the port. For this kind of purpose, like a network segment types, the Modular Layer 2 now the supporting the flat, grid, local, VLAN, and VXLAN. So if you want to implement this kind of network type using modular layer 2, then you need to configure in the configuration file like this: type, drivers, local, plat, VLAN, GRI, or VXLAN like this. And the modular layer 2, the mechanisms, the modular layer 2, the plugin have been re-implemented as mechanisms with a common code base. So using code reusing, we can implement this modular layer 2, the mechanisms. So modular layer 2 mechanisms normally use what? Code reuse to eliminate much of the complexity around code, the maintenance, and the testing. So for this kind of purpose, modular layer 2 drivers now include this one: Arista, Cisco, Nexus, Hyper-V, L2, and the Namespaces, and OpenvSwitch like this. So in this video, as a default modular layer 2 mechanisms, I will use OpenvSwitch or Namespaces, what the other things. Using this keyword, we can define this kind of type of modular layer 2 mechanisms. Tenant and provider networks. At first time, I already told you the tenant network. Tenant network is a kind of the domain name. So each tenant name have their separate network addresses. This one, tenant network 1, tenant network 2. So tenant network 1 network is a different name, and each this tenant name and tenant name will have the different network addresses as well for this kind of virtual machines inside or within this kind of tenant network. But this kind of tenant network at first time will be assigned to use the private network addresses. Then this kind of virtual machine need to connect it to the external network address. For this kind of purpose, we can use provider network. Using provider network, this kind of virtual machine can connect it to Neutron router. Neutron router need to be connected to physical network, and this physical network will transfer this kind of packet to external network such as internet access. So tenant network created by the users but connected within the project. Each project, they need to be created this kind of tenant network by the users, and this kind of tenant network fully isolated. Why? Because this one now normally this kind of tenant network can be created without any connection to external network. So normally fully isolated and are not shared with other projects. At first time, as a default, cannot be shared with the other project. Project means the other tenant. OpenStack network support a range of tenant network types. So here, well, when you create this kind of tenant network, you need to define this kind of network types. First, the flat. Flat means all instances inside on the same network. In this case, if you give the same network address to all your virtual machines, then in this case, you can use the flat network types. Local. All instances reside on local computer host. If you give all same network address inside the local computer host, then you can use the local network type. VLAN, I already told you, this one can support the create multiple providers or tenant network using the VLAN. Even if we are using one switch, but using VLAN, we can create various private network address or tenant network address. If you use this kind of VLAN, even if each the instances have the different network address, but they can communicate with each other. Using VLAN, the virtual machines also, this kind of instances can communicate with the dedicated servers, firewalls, load balancers, and other network infrastructures in layer 2 VLAN. Normally the layer 2 use the switch. Inside the switch, we can create various the VLAN as well. VXLAN or the GRE, this one use network overlay to support the private communication between instances. If you want to use instances for the communication of the private communications between the instances, then we can use the VXLAN or GRE network types. This kind of the network router to implement the VXLAN and GRE, we normally can use the router service. So router service always must be the enable the traffic to traverse outside of GRE or VXLAN tenant network. If you want to permit your virtual machines to access outside of the GRE or VXLAN tenant network, in this case, you need to create the router service. This kind of router service can connect directly connected tenant network with external network. So tenant network normally will use the private, but need to be connected to external network using what? Using routers. So router provides the ability to connect the instance directly from external network using floating IP address. Using the router, the users from outside anytime can access this kind of the instances. Why? Because this kind of router can provide the floating IP address. This kind of floating IP address needed to connect this kind of instance to use private network addresses. So this is a kind of OpenvSwitch tunneling. So now here instance the virtual machine inside the host 1. This one also instance, the host 2 IP address is different. And this host and host connect each other using this pitch called the switch. So in this case, this instance 1 and instance 2 needed to want to connect each other. So in this case, this kind of instance must be connected to this kind of virtual bridge, for example, like this. And this kind of virtual bridge need to connect it to this kind of OpenvSwitch. This kind of OpenvSwitch need to create this kind of the tunneling service using GRE. Then this kind of GRE using this kind of GRE tunneling, this instance can connect it to the other instance in different compute node. This instance also must have this kind of virtual bridge and connected to OpenvSwitch with the port. Then this instance also can connect it to the instance located in different host. So we can create this kind of tunneling as well using GRE. So OpenvSwitch means tunneling traffic, this one, enable instances in a different network. Even if they are located in the different network, we can connect each other using this kind of the protocols, GRE or VXLAN. This kind of the tunneling features always must use this kind of physical OpenStack network host. Using this kind of, based on this kind of the OpenStack networking host, the tunneling can allows the VLANs to span multiple physical hosts. Even if many kinds of physical hosts, anytime they can use each other using this kind of tunneling features. And this kind of tunneling feature also will use the GRE or VXLAN, this kind of the protocols. Instances communicate as if they share the same layer 2 network. It means that even if this kind of instance located in different hosts or using different network addresses, but they can communicate each other located in same layer 2 network. Same layer 2 network normally means is the switch, OpenvSwitch. So OpenvSwitch now support the tunneling with the VXLAN or GRE encapsulation protocols. So if you have the separate tenant network in different hosts, in this case you have to use the OpenvSwitch, and OpenvSwitch also need to configure VXLAN or GRE for this kind of tunneling connections between different physical hosts. So let's check here network informations between the Neutron and the Nova. At first time, Neutron needed to be connected to the internet as the external network using this kind of interface. And this kind of the external network interface will have this kind of network addresses. This kind of the Ethernet to one external network address needed to connect this kind of BREX. BREX means the bridge the external. So this kind of bridge external net interface will have this kind of network address. And this kind of external virtual the external interface needed to connect it to router this kind of namespace and namespace. So each this kind of Neutron will have as a default as called router namespace and DHCP namespaces. Using this kind of namespaces connected to the BRINT. BRINT means the bridge integration. And this kind of the integration did to BRETH0. BRETH0 means it's a virtual interface to connect it to tunneling physical interface. So this one, ETH0 can be used, and this kind of the bridge integration will have the tenant network address, and this kind of tenant network address will be assigned to virtual machines in Nova, and this kind of interface connected to the ETH0. ETH0 normally can be used only the tunneling, the service instance, the tunneling. So now the Neutron and the Nova, these two nodes connected to be this kind of instant tunneling network addresses. So in my case, now you will use this one, external network, this one, tenant network, this one. So it means the virtual machines will have this kind of network address. And instance tunneling as well, ETH0 will have 10.1.1.0/24 network addresses for the tunneling service. Also, Nova compute node also will have this kind of virtual machine, and this kind of virtual machine need to use this kind of virtual interfaces like a QBRXYZ, and the bridge integration, this one is the same, and the bridge ETH0, this one also virtual interface to connect the physical interface for use of the instance tunneling service. So each this kind of Nova and Neutron must have this kind of virtual interface, the BREX, BR integration, or BRET0. Here, QBR, BR integration, BRET0 like this. Normally this one belongs to where? Virtual interfaces. Using this kind of virtual interfaces, virtual machines can connect it to Neutron service, also access internet service as well. So here in the previous page, I show you two kind network namespaces, DHCP and the router. So this kind of network namespace means virtual routing and the forwarding service. Also, this is a isolated environment which on networking stack. So for this kind of purpose, normally for this kind of purpose namespaces, this kind of the virtual router, especially for the layer 3 forwarding service, can be run on the physical device. So if we are successful to create this kind of virtual router for the network namespaces, then this kind of virtual routers will have their own virtual routing table, network interfaces, and IP table setup as well for NAT and filtering service. If we use network namespaces also, we can reuse the addresses. We can use network namespaces to prevent the collision between physical networks on the network host. Provided networks, I already told you, tenant networks can be created by OpenStack users, but provided network must be created by OpenStack network administrators, and these provided networks will map directly to an existing physical network. And this kind of purpose, we can use the two kinds of network types, flat and the VLAN. Using the provider network, we can allow the provider network, and this kind of provider networks can be used to be shared among the tenants. Between the tenants, we can use the provider networks. Using this kind of provider networks, anytime all the tenants can be connected to each other. So in this video, I will use this kind of the Neutron installation types. So controller node here, networking, and the network node here, networking, and the compute node, networking here. And if you check this one, network interface, for the management service, I will use this IP address, this one, and this one. In case of network node, we'll have the three network interfaces. In the instance tunnel, I will use 10.1.1.0 network address. For the external network service, I will use this 192.168.10.0/24 networks. In case of the compute node, only two, this one, for the management service, and instant tunneling service, this one will use with the communication with the network node. So here, In my case, controller node, the ETH0, ETH1, and the ETH2, BR, BRINT, external bridge integration. This one is a virtual network interface. The controller node will have this one IP address. The hostname is a master.chol.com. Network node, node2.chol.com, management the interface, instance the tunneling interface, this one. For the external, we'll have the ETH2 and we'll have this kind of network address. For this kind of purpose, the ETH2 in network node will be on number. And the tenant network, this one, 10.10.10.0. So this network address will be assigned to virtual machines in compute node. And the compute node, hostname node 1, the management, this one, instance tunneling, this one, network address must be same, this one, in network node.